Okay, very good. Well, thanks for inviting me. I'm a cognitive scientist. I was very happy to see Fumia mention the 2003 workshop on embodied AI as one of the historical roots of this conference. Partly because I was one of the speakers back then, which I guess makes me very old. But I was also happy to see that reference because I'll be talking about some of the old problems that we were discussing 20 years ago and which are resurfacing now in new ways, you could say. Okay, a quick overview of what I'm going to talk about. It's not very much. It's of course, since it's only 10 minutes, but what we'll be talking about is the human interpretation of robots as intentional agents. And that's maybe important to say already from the beginning. I'm not talking about how to build embodied AI, but I'm talking about how people interpret embodied AI. Okay, I'll be talking about the symbol grounding problem a little bit and the variation or a new version of that, which I refer to as the observer's grounding problem. And I'll talk about the role and implication of embodiment in HRI. So again, I'm talking about the interaction, how people interact with embodied AI systems, not so much about the embodied AI as such. Okay, the symbol grounding problem, just the 30-second version here. I'm sure everybody has seen and heard this before many times. This was discussed, like 40 years ago in AI, and the problem pointed out was what John Searle, a philosopher, referred to as the lack of intentionality. And by that, he meant that the computer programs simply lack the capacity to relate the symbols that they reason with to what those symbols are supposed to refer to in the outside world. In embodied AI, we think that we've solved that problem by various approaches to what's called symbol grounding. This illustration just comes from a paper by Luke Steels, written, I think, 15 years ago, which explicitly is called "The Symbol Grounding Has Been Solved." And that's the way many people in embodied AI look at the problem, as something that is solved, because, embodied AI is not like a computer program, but embodied AI is in the world, and it either dispenses with representations completely, or it deals with representations that are grounded in the interaction between agents and their environment. Okay, so you might think that old problem of AI systems lacking intentionality might simply be solved. If we have a quick look at what intentionality, because that's a very complex concept that philosophers have been discussing for at least 200 years. If we have a quick look of what people mean by intentionality, and there are at least two different senses of the term. There's on the one hand the sense that's mostly discussed in philosophy of mind. Here's a quote from John Searle saying, for example, that intentionality is the general term for the various forms by which mind can be directed at or be about objects in the world, and so on. So that's the notion of intentionality that people were talking about when they were discussing the Chinese room, the symbol grounding problem, and so on. Then there's having technical problems here. There's another notion of intentionality of behavior discussed in psychology, social psychology in particular, which has to do with behavior being intentional or unintentional. And as the quote here says from Bertram Malle and colleagues, intentionality brings order to the perception of behavior in the sense that it allows perceivers to detect structure in terms of intentions and actions in humans' complex stream of movement. The diagram there just illustrates what they call the folk psychology of intentionality. What are the ingredients or the building blocks of how we interpret actions as intentional or not intentional? We don't need to go into the details, but it's good to keep in mind. There's a philosophical notion of intentionality, there's a psychological, and they overlap, but they're not exactly the same. Okay, let's get to robots then. And here you'll see that most of the examples that I'm talking about are the kind of robots that people can encounter in everyday life already. So I'm not talking about more advanced robotics like the biohybrid robots that the plenary speaker was just talking about. But I'm talking about the kind of robots that people can encounter in the real world. And if we look at robots like that, let's take the example here. This is just a lawnmower robot approaching its charging station. You could say they certainly appear intentional in that first sense of intentionality that I was just talking about, because they seem to, lawnmower robots, for example, typically have a map of their environment, and they know where their charging station is and so on. So that type of system could be said, could very well be argued to be intentional in that original sense, in that philosophical sense of the term. And we, here are just some more illustrations of robots that we certainly think of as being able to detect objects in the world, or in the case of the accident illustrated there at the bottom, of not being able to detect objects in the world. And that is something that certainly is important to our interpretation of robots and how we interact with robots. And the robots are, of course, also hopefully also interpreted as intentional agents in the second sense that I referred to as the psychological sense or the social psychological sense. So they are hopefully interpreted in the sense that we can attribute intentions to them, and we can predict their behavior based on those intentions. If you just take the two images on the left here, it's of course predictable that the robot lawnmower will approach its charging station when its battery is running low. It doesn't do that by chance, but it does that for a reason. And hopefully in the case illustrated at the bottom there, if you're a pedestrian and you're encountering a self-driving vehicle, you don't just need to observe what it's currently doing, but you want to know what will it be doing in a couple of seconds from now. Does it understand that I want to cross the road, and will it slow down in order to let me do that? So much of this type of representation of this type of interpretation of robots as intentional agents has both of these aspects of intentionality to it. So reference to objects in the world and reference to future actions and events. Okay, so the interesting question, since I'm a cognitive scientist, I'm very interested in how do people actually do this? How do people know what robots know, and how do they predict how robots will act? And there's a lot of work on this. We recently published a systematic review of 155 empirical studies of how people interpret robots as intentional agents. And we no need to go into the details here, but what's interesting to note is we know quite a bit about the determinants of that type of interpretation of robots, and we also know quite a bit about the consequences. So we know why people interpret robots as intentional agents, and we also know when they do it. But we know, and that's the black box in the middle here, we know very little about the underlying mechanisms, so the cognitive or psychological mechanisms of how they do this. I can quickly illustrate some of our own empirical work on this. This is some work from 5 years ago, where we asked people to explicitly interpret and describe behavior of both humans and humanoid robots. And one thing that we found was that they described humans and robots in very similar terms. And in that case, you could, of course, say, okay, yeah, but you're asking them in terms of human language, so that, of course, they will describe them in human-like terms. In later work, we've looked at this using a more explicit, a more implicit approach. So we're not asking people to give verbal descriptions, but we measure their reactions in terms of reaction times and so on. And results in a nutshell are that, as the quote here says, a majority of participants in our experiments predicted robot actions based on highly anthropocentric assumptions about their visual and auditory capabilities. That means people seem to think in these particular experiments that robots function very much like people. And again, you might say, okay, but that particular robot that you're showing here actually looks a bit human-like. So of course they interpret it in human-like ways. But we've also done other experiments where we're looking at, on visual and cognitive perspective taking towards autonomous vehicles. So you could say robots that don't look like people at all. And also in these experiments, we also find that people tend to assume human-like perceptual and cognitive capacities. So in these experiments, for example, people assumed that cars could see what human drivers would be able to see. And they also assumed that self-driving cars had human-like cognitive capacities like object permanence, for example. Okay, I'll move on quickly. So this is then what I call the observer's grounding problem, which is of course related to the symbol grounding problem. In this case, the problem is not with the AI as such. It's not that the AI is grounded or ungrounded, but it's the fact that the person interpreting this robotic AI system interprets it in his own terms. So based on his own grounding. I'll skip a little bit here in the interest of time. So what I want to point out is we really have two different grounding problems here. One is the traditional symbol grounding problem in which the AI system was the problem, and it's the symbols inside the AI system that lack the grounding. And in embodied AI, we think we've solved that problem either by grounding the symbols or by completely dispensing with symbols or representations in general. But what I just described as the observer's grounding problem in human-robot interaction is that here it's the human observer that is the problem. And it's the observer's interpretation and expectations which are grounded in their own embodied experience. Rather, so they're explaining the robot's behavior in terms of their own internal mechanisms, which might or might not match the robot's way of seeing the world. Okay, and that particular problem is to some degree unsolvable in the sense that what's called the other minds problem in philosophy is unsolvable. So that means we simply don't know exactly what goes on in other people's heads. And we also simply don't know what's going on in, for example, in cats and dogs' heads. But we learn to deal with that uncertainty. So, and then of course you might say, well, we managed to interact with people and we managed to interact with cats and dogs, for example, although we have that problem that we don't really know what's going on in their head. So maybe with robots, it isn't really a problem. Okay, and to that, of course, you can react in two different ways. And this is my last slide. So there, you could say there are two different ways of looking at embodiment, and I hope this will lead to some discussion. On the one hand, there are people who would say, okay, let's make robots more human-like. And I would say that the previous talk, which was great, by the way, the previous talk was an example of that. If you, for example, try to equip robots with human-like facial expression. So that position here is just summarized by saying let's make robots more human-like. So the starting point here is that embodiment is fundamental to social interaction. And people are used to, and they're good at embodied social interaction with other people. So to facilitate natural human-robot interaction, you could argue that, yeah, let's make robots more human-like in appearance, in behavior, and so on. On the other hand, you could argue almost the opposite. You could say, okay, let's face the facts. Embodiment is fundamental to social interaction. That's exactly the same starting point as on the left side. But there are many ways in which robot bodies are never going to be human-like. If we just take the example of disgust, for example, being expressed in one of those virtual agents that the previous speaker talked about, disgust is, of course, a bodily reaction to something that you're eating or smelling or seeing. So that's something that is natural for human bodies, but it would be very difficult to think of a robot that actually could feel disgust. Okay, so the conclusion here might be, well, we see in many experiments that people are confused about robots and humans how much they are alike, and to what degree you can interpret robots based on what you know about humans. So the conclusion here on the right side might be, let's not confuse people by making robots appear human-like. People need to understand that robot perception, cognition, and so on is simply not human-like. So, and that's just the little point that I was trying to make, that taking embodiment seriously can be interpreted in two very different ways here, if we look at the case of human-robot interaction. Okay, and that was my last slide. Well, I have one more, but that just asks for questions and comments, and we're not doing that right now, I think.